Hello, everybody, and welcome again to your channel, Thermal Engineering Concept and Principle. This is Professor Ali Tarrad. I will introduce to you a short video which describes the flow term of the fluids in the shell and tube heat exchanger. Of course, we have passed through this topic before, but I realized that it is so important to describe the flow pattern on the shell side again. And in this episode, which I will go through a detailed description of the two fluids that are passing through the heat exchanger. Let us go directly to the description. Let us have a look at the flow pattern on the shell side of the shell and tube heat exchanger. Here we have a simple diagram for the shell with the baffles fixed. And let us consider this shell is occupied by a tube bundle composed of 12 tubes with fluid passing on the external side. And let us take one of these tubes uh, as shown in the shell, just to show how the fluid flow patterns on both sides could be. We have inlet and then passes between these baffles, and at the end exit on the other side of the heat exchanger. And we have two fluids, the blue one on the shell side and the red is passing in the tubes. And we have a complete or a true counter flow and cross flow for this type of arrangement. And we should mention here TEMA standard, which is Tabular Exchanger Manufacturer Association, which is responsible for creating a standard for manufacturing these types of heat exchangers, and an abbreviation called TEMA. And especially the thicknesses of these parts of heat exchanger, uh, which is composed of tube sheets, plates, the shell thickness, the tube, including the effect of corrosion, erosion allowances, and so on. Everything is put in a standard of TEMA. And the tubes which are used in the uh, manufacturing of these heat exchangers are specified by TEMA to be between 9.5 millimeter and 50.8 millimeter. The fluid flow arrangement in the heat exchanger, and as we are talking about shell and tube heat exchanger, is the same for other types of heat exchangers. So there are two main types of fluid arrangement in the heat exchanger. The first one is called the counter flow pattern, and the second one is called the parallel flow pattern. In the first type, the fluids on the shell side and tube side entered the heat exchanger from opposite ends of the heat exchanger. Therefore, as they are passing through the heat exchanger, the flow is counter flow. And at the same time, when we talk about the other type, the fluids enter from the same end or the tube on shell sides, and they are leaving at the other end at the same direction. Therefore, these fluids, as they are passing through the heat exchanger, they are following a parallel path. So if we talk about the counter flow heat exchanger, if we have a look at the blue line, which represents the cold fluid, it enters at T sub Ci and leaves at T sub C naught. And when we have a look at the exit temperature, it will be there is a possibility to be higher than the exit temperature of the hot fluid. On the contrary, there is no possibility if we have a look on the right hand side um, graph, the cold fluid as it enters at T sub Ci, then it leaves at T sub C naught, which there is no possibility to be higher than the exit temperature. And in general, all the heat exchangers are preferred to have a counterflow. And in the counterflow, there is a uniform temperature distribution and they provide a good temperature difference between both fluids. So it is more efficient than the parallel flow pattern. So we now know that there are two flow uh, arrangements in the heat exchanger. The first one is called the counterflow pattern, and in this pattern we may calculate what is so-called the logarithmic mean temperature difference and the mean temperature difference, which is defined as F sub T times LMTD. And F sub T represents the temperature correction factor, which is presented in a graphical and mathematical expressions in the literature. And LMTD represents the log mean temperature difference. So if we substitute the values of both the fluids, inlet and outlet, in this expression, then we may get the mean temperature difference across the heat exchanger. Similarly, we have the parallel flow, and if we use the same conditions, then we will be able to estimate delta T mean, which represents the mean temperature difference. And if we take uh, an example for a typical values, we have found that the mean temperature difference for the counterflow is greater than the parallel flow, and hence we need lower area for the heat exchanger for the counterflow when compared to the parallel flow. And that means in a typical calculation, if we have specified the heating load and we know the conditions of the inlet and the exit temperatures for both fluids, then finally we may estimate the surface area required. For the counterflow, we have an effective length for the heat exchanger is around 800 millimeters. And for the same conditions, If we choose the parallel flow, then the effective length of the heat exchanger will be 950 millimeter. And that means surface area bigger, then the cost will be higher, and at the same time, the maintenance and other parameters during the operation of this heat exchanger will be higher than that the required for the counter flow range. This is just to show a comparison which flow directions are preferred. So this example shows that the uh, counter flow arrangement is better than the parallel flow arrangement. Dear friends and followers of this channel, thermal engineering concept and the principle, we have arrived to the final of this episode. It is the closure. In this video, we talk about the operation description of flows inside the shell and the tube heat exchanger. We have mentioned the different flow arrangements through the heat exchanger, the shell and tube on both sides, on the shell side and on the tube side. And we have mentioned the counterflow and parallel flow arrangements. And finally, we compared the available flow patterns, and we have arrived at the point where we prefer the counterflow arrangement when we want to apply that for industrial application. We have some useful resources and references. In a link, you may find that down in the description box. If you found that the present video is useful to you and others, please like the video, subscribe, and share it so we can arrive at the main objectives of this channel. Thank you for listening and watching this video, and see you on the next time. Bye bye.